We're going to talk this morning really about fact fluency, but as John said, we've been doing this since, I think it's 1985, we started looking at this whole issue of math fluency. We never started out trying to study math fluency. We started out looking at problem solving, all right? And found that so many of the kids we were working with were having difficulty in problem solving because they couldn't add, subtract, multiply, and divide, that we went back and said, whoa, there's some other problem here that we've got to look at. And that's what got us started even going down this road. So that's really what I want to share with you, is kind of that path of research that we've been on for the last, well, over 20 years now. The interesting thing is, you're all familiar with the National Math Panel report, and I was quite happy to see the direction they were taking, because they talked about really paying attention to the research, especially around the mutual benefits of conceptual understanding, procedural fluency, and automatic, i.e. the quick and effortless recall of facts. So I'm sure you read that report, and I think, like in reading, the math community is now starting to understand the importance of fact fluency in terms of its impact on high order mathematics. What is fluency? Why do we even care about it? Well, as it turns out, fluency is the building block of expertise in all things we do well. I don't care what you do, it doesn't matter. If you do it well, you do the subcomponents of that terminal task with speed and accuracy, whether it's, flying an airplane, driving a car, playing chess, anything you do well, you do it with speed and accuracy, the underlying skills with speed and accuracy. That's true in reading, math, spelling, writing. Any academic task also requires that. And I think we're really starting to understand now why that's so important. And the way that I'm going to talk about it today is the ability to demonstrate knowledge or perform skills both accurately and quickly without hesitation. We all often talk about it almost automatic. You hardly even think about it. So how does that happen? Well, it starts obviously in the brain. Okay, we know that. We've been studying, how fluency and the brain interact for a number of years. If I put this up on the screen, virtually instantaneously, you can retrieve that answer, okay, without even thinking about it. How does that happen? Well, it actually starts through your senses, all right? So you're taking information in through your senses. Now, in that case, it was through the sense of sight, all right? But as you're sitting here right now, there are a lot of other things going on. You're hearing things, you're touching things, you're smelling things, you're tasting things. All of those things are coming in to your brain, all right? Now, the important thing is that you filter out those things that are important. For example, the taste of your coffee or eggs right now isn't that important, all right? Hopefully what I am saying is important, so you're listening to that. Anything that's not important simply gets filtered out, all right? Now, if you're focusing on the taste of your eggs and not me, there's something wrong. But anyway, we'll go on. All right, so what happens is you filter things out. Now, one thing we know is that good learners are good at filtering things out, and there's a lot of reasons for that. Your past experiences help you filter. Knowing what's important helps you filter. There's actually a theory of autism right now that says that autistic kids are not good at filtering, and they are bombarded by a lot of extraneous stimuli that really aren't that important to that task at hand. All right, so assuming that 7 plus 5, that set of numbers comes through, the next point that it gets to in your brain is now something called immediate memory. We used to talk about short-term and long-term memory. Now we've broken short-term memory down into two parts, immediate and working. So the first part of your short-term memory that this goes through is called immediate memory, and it also is a form of filtering. Information will stay there for about 20 seconds at the max, all right, and often much less than that before it is either moved on through into working memory or it's filtered out. It's another form of filtering. The important part is working memory, all right? That's where we do all the hard work. That is really where we process most of the information that goes on. I'm going to talk a lot about working memory today because that really is the bottleneck for most struggling kids with math facts. That's where they get into trouble. Now again, information can stay in working memory for a few seconds to even a few days. For example, if you're in a hotel in DC you probably know what your room number is, okay? You hold that in working memory. If I ask you next week what room number or what room you stayed in, you may not even, you won't remember the room, you may not remember the hotel. I mean, it's just, that stuff just falls right out. You don't need it, so it falls out, all right? But we do process information there, and this is the interesting part, because what happens in the brain is we either process information as it's coming in, or we actually retrieve information from long-term storage and use that. Now that's what happened when I put up 7 times 5 on the screen. What you did was retrieve a stored answer to that problem from long-term storage. You didn't go, hopefully you didn't go through and skip count by 5 or something to get the answer. You simply retrieved an answer to that problem. And for struggling students, they tend not to store that information or retrieve it. What they do instead is they will try to process that in a very inefficient way in working memory. And that's what we see with most special ed kids. A lot of at-risk kids do the same thing. So if you ask them what 7 plus 2 is, all right, they'll go 7, 8, 9. They reproduce it almost every time. And the problem is with that is they're using their working memory for the wrong thing. And we'll talk more about this. They're processing too much information because that working memory is very finite. You don't have an unlimited working memory. It's a very finite amount of processing capacity that we all have. So why is that important? Well, as it turns out, when students lack fluency in foundational skills, we're talking about reading, math, spelling, writing, whatever it is, when they try to apply those fundamental skills or those foundational skills to things like, higher order math, reading for meaning, creative writing, what we find is that they're very, very slow. They have difficulty with the task, and they make lots of errors. And the reason being is they haven't stored that information. They're very, very slow at processing that as if they'd never seen it before. That's what happens. Here's an example of that. Here's a student who's doing a simple single-digit addition task. 1 digit plus 1 digit. Now, I'll warn you, I've got a little problem with my video here, but you'll get the idea. Just watch what he does. Now, every answer was correct. That's the good thing. He understands the concept of what he's doing, but every time he sees a fact, he reproduces it, okay? He reconstructs the answer to that, even if he's seen the same fact, over and over again. And we see lots and lots of kids like this, that they never store those answers, they reproduce them. Now, why is that a problem? Well, as it turns out, remember I talked about working memory being a finite resource that we can allocate to any task. In Jeffrey's case, he's using all of his human processing capacity for a very, very low level processing task. There's nothing left over then for him to think about more difficult things like multiple digit addition or addition of fractions or anything like that, because his working memory is filled just keeping track of those low level skills. If you watch him, some very interesting things are going on. Once he lost track and he had to start over again to redo it. You can tell what he's doing. He looks at the 2 add-ins, all right, selects the larger of the 2 and sets a counter. So if it's 7 plus 5, he goes 7, 8, 9, 10, 11, 12. And he will increment every time. And 1, you saw the minimum add-in was larger than 5. He had to go up here to get the rest of the add-in. I mean, he just, it's a very, very cumbersome process, but it's so typical of struggling students of what we see. Now, you and I would take up such a small amount of working memory with that task. And when I said 7 times 5, you simply immediately said 35. And then you were able to still think about other things. Jeffrey would have to go through and either count by 5s or some other way to do that, and he's using all of his working memory for the wrong thing. So The bottom line is, why is fluency important? It simply frees up working memory.